Hey guys, Mr. Backerberg here. In this video, we're going to take a look at end behavior. Now, when we're talking about end behavior, we're talking about what's happening on the far right-hand side of our graph and what's happening on the far left-hand side of our graph. And horizontal asymptotes are one type of end behavior, but other things can happen as well. Not every graph has a horizontal asymptote in it. So we're going to look at a few examples here, and we're going to talk about what happens at the ends of our graph. So the first equation I want to look at is y equals 3x over x squared plus 1. Now, we're talking about end behavior, so we're talking about what happens as our x values get really big and really small. So looking at the denominator right now, we're taking x and we're squaring it, and then we're adding 1. But what I really want to think about is as we're plugging in larger and larger values for x, once we square it, the adding 1 really isn't going to have that big of an impact on our denominator. Like if we plugged in an x value of 10, then 10 squared is 100. When you add 1 to 100, it doesn't have that big of an impact. Or if we keep going further out to the right, if we plugged in an x value of 100, well, 100 squared is 10,000, and then if we add 1 to 10,000, again, it's not having that much of an impact. So I actually want to think about for a second, I want to think about not having that plus 1 on the end. Then we'd have just 3x over x squared, and we can actually simplify that down a little bit to just being 3 over x. So what would happen here is we keep plugging in larger and larger values for x, our y value is going to keep getting smaller and smaller decimals. So what's going to happen is our y value is going to approach 0. And similarly on the left-hand side, if we were going really far in the negative direction, we'd keep getting decimals that are closer and closer to 0, but on the negative end. So we can really think about this graph having similar behavior to the graph for the line y equals 0. And I'm going to show that on my calculator. So in my calculator, I have both of those equations typed in. I have the 3x over x squared plus 1, and I have the y equals 0. So if I hit graph, I can see that my original equation, that 3x over x squared plus 1, as we're getting larger and larger values for x, it is approaching that red line. It's approaching that y equals 0 line. So as far as end behavior, our graph is approaching a y value of 0, as we move out to the far right-hand side and as we move out to the far left-hand side. Now, as we're looking at this example, we're going to use an equation that's very similar to what we just used in our first example, but I'm going to make one small change. Instead of just being 3x on top, I'm going to make it 3x squared. But now, like we were talking about, we're going to be dealing with really big x values. So in the denominator, again, that plus 1 isn't going to have that much of an impact. So we can really kind of ignore it for a second. So we're going to look at 3x squared over x squared. Then if we do a little simplifying in here, we're just going to get y equals 3. So what should happen as the x values keep getting very large towards the right and very small towards the left, our graph is going to have very similar behavior to the line y equals 3. So in my calculator, I have both of my new equations typed in, 3x squared over x squared plus 1 and y equals 3. So if I hit graph, as we're working our way out to the far right-hand side, we can see that our graph is approaching that y value of 3. And same thing on the left-hand side. As we're working our way further to the left, again, our graph is approaching that y value of 3. I'm going to keep adjusting this example ever so slightly. So instead of having 3x squared on top, I'm going to make it 3x cubed. Again, as our x values keep getting larger and larger, that plus 1 on the bottom really doesn't matter. So this is like having 3x cubed over x squared, which we can simplify down to just 3x. So as we look at this, as our x values keep getting larger to the right-hand side and smaller to the left-hand side, this graph should display similar behavior to the line y equals 3x. So again, I have both of my new equations typed in, 3x cubed over x squared plus 1, and my y equals 3x. So if I graph these out, So as we're working our way from the origin out to the right, this blue graph is gradually getting closer and closer to that line y equals 3x. And as we work our way to the left, same thing is happening. Our graph is getting closer and closer to that line y equals 3x. So we can say that they have similar end behaviors. I'm going to take this example and I'm going to bump the power up on top one more time. So I'm going to make that 3x to the 4th power. Now again, as we're thinking about x values getting very, very large, that plus 1 on the bottom again, it doesn't matter. So this is really like having 3x to the 4th over x squared. So we can simplify that down to be 3x squared. So as this graph goes further out to the right-hand side and further out to the left-hand side, it should display similar behavior to the graph of 3x squared. So in my calculator, I have those new equations typed in, 3x to the 4th over x squared plus 1 and 3x squared. If I graph those out, okay, again, we can see that as we work our way to the right-hand side, these graphs are getting closer and closer together. Same thing going out to the left-hand side. Our blue graph is gradually approaching our red graph ever so slightly. So again, these graphs have similar end behavior. That's going to be it for this video. Thanks for watching.